Hey everybody, this is just me, Mr. Rohr, trying to teach you a short lesson on what standard form is useful for. We talked about yesterday how standard form is this template. When you write Ax plus By equals C, that is when you put numbers or equations in the form of x's, y's on one side equals numbers on the other side. Here's a quick example of an equation that's written in standard form. Notice the x's and y's are on the left-hand side, and I don't know, number 10 on the right-hand side or something like that. There's an equation in standard form. Standard form's neat, it's organized. There's a rule that you're not allowed to have any fractions or decimals in it, and so it kind of looks clean and usually isn't too scary looking. And that's the primary benefit of standard form. It's not so helpful for graphing things usually, but it's very helpful when we're combining equations of lines in with other lines later on in Chapter 7 when we talk about systems of equations, for instance. It is pretty easy to find intercepts with equations that are written in standard form, so that's kind of nice. It can also graph lines that are straight up and down. Y equals mx plus b can't do that because the slopes are undefined and there's no y-intercept, so there's no b value. But straight up and down lines are just x equals something, which is a simplified version of standard form, so that's kind of nice. What I really want to talk about today, however, is that standard form can be a really nice template to use to write equations. So far, the examples we've done, we've been using y equals blank x plus blank as a template, and it's kind of nice, but it isn't necessarily the easiest thing to do. Today, we're going to get rid of that template and start using instead this template. Blank x minus blank y equals blank. And if you understand what those blanks are, it's a pretty easy template to use. So, when you have an equation that's written in Ax plus By equals C form, the A, the number in front of x, actually has some meaning. That is a change in y. That's a delta y. That's a rise. And the b in the number also has some meaning. That's a change in x, or a run. Now technically the slope gets a little bit confusing. The sign isn't exactly right all the time, but that's not that big of an issue to fix. The c value at the end, that is a number that's related to how far away the line is from 0, 0. And in class I demonstrated a little picture of this in GeoGebra. We also sang a standard form fight song. Sorry, you're not going to get that in this video, but that's just more motivation to come to class, huh? What we did in class was we worked with this new template to answer some equations, some questions that we've answered before, but we're going to answer them in a different way. So you can tell or see the equation here. Write an equation for a line that goes through the point 311 and with a slope of 4. And we've done stuff like that before. However, today I want to use a different template. I want to use this shape of an equation to answer that. And so the last time we answered a question like this, I said start by writing the template, and so I'm going to do that. Blank x minus blank y equals blank is our new template. And in this first blank, we need to write the rise. So in here, I got to figure out what the rise of my line is. In the second blank, I'm going to write the run. And then the third blank is just a number that has to do with how far away the line is from 0. I'll show you how to calculate that in a moment. First, the rise and the run. So the way we get rise and run is by figuring out what the slope is. And thankfully, they told us the slope. Slope is 4. Unfortunately, it's not a fraction, so we can't see the rise and the run immediately. But it isn't hard to write 4 as a fraction. 4 is the same thing as 4 over 1. And remember, slope is the same as rise over run. And so 4 is the rise, and so that number goes here. And run, 1 is the run, and that number, it goes in front of the y. That's our b value. And we're almost done. We almost have an equation that's in the right location. The only thing we need to do now is figure out what c is. And in order to find C, we need to plug in a point. And so the point they told us, 311, is an x and a y coordinate. And so we'll put the 3 in for x and the 11 in for y and calculate what that gives us. 4 times 3 minus 1 times 11. 4 times 3 is 12. 1 times 11 is 11. 12 minus 11 is 1. That number is what the third blank is. Doesn't necessarily have a whole lot of meaning, but that number, 1, is what goes in this third blank, and we're actually done. This equation, 4x minus 1y equals 1, is an equation of a line that goes through the point 311 and has the slope of 4. So we got one more example, same basic sort of thing. I'd like to come up with an equation of a line that goes through these points. And so we could use the y equals blank x plus blank template from before if we wanted to. But the point of today's lesson is to try a new template. And so we're going to use the standard form template, something x minus something y equals something. And the first blank here is rise, and so to find the rise and eventually the run, I need to find the slope that goes through these points. So the slope formula is y2 minus y1 on top of x2 minus x1. The top half would be the rise, which would go in the first blank. The bottom half will be the run, that'll go in the second blank. So with our numbers, y2 is 13, and y1 is 4. So 13 minus 4 is the rise, that's 9. That number goes here. And then the second numbers, the x's, the run, 5 is the second x, and I'm going to take away negative 2. Taking away negative 2 is the same thing as adding 2. So 5 plus 2 is 7. That's the run. And that would go here in this blank. For comparison's sake, if I was going to write this in slope-intercept form, this fraction, 9/7, is what I'd have to put here for slope. And that'd be kind of an ugly problem to work through, eventually find the b value with, because fraction, not so fun. But standard form doesn't have any fractions, and so it's much easier. To figure out the third part of standard form, I need to plug in a point. And I actually have two options. I could plug in this point, negative 2, 4, or I could plug in 5, 13. The green point or the yellow point, doesn't matter. Truth is, you'll get the exact same number out both times. And so I'm purposefully going to choose the yellow point, 5 and 13, only because it's positive numbers, and I don't feel like dealing with negatives. Negatives kind of sometimes throw me off and give me a chance to mess up. So let me make a little space here. And we'll take those numbers, 5, and plug that in for x. And 13 and plug that in for y. So I've got 9 times 5 minus 7 times 13. 9 times 5 is 45. 7 times 13 is 91. And if I subtract 45 minus 91, the negatives win by about 46, exactly 46. That's the C value. That's what goes here. So that's my final answer then. 9x minus 7y equals negative 46. So a lot easier than taking 5 and 13 and plugging them into this guy. If I put a 5 here and a 13 here, I'd have to multiply that out, and I'd get some fractions of sevenths and all that sort of stuff, and then have to subtract that from both sides and find a fraction answer for b. Which would work. It's still the same line, but man, that was not as much fun and ease as simply using this new template. So anyway, that's standard form, and I hope you'll benefit from trying that on your assignment tonight.